In algorithmic crypto trading, the most sophisticated strategy is bottlenecked by one physical constraint: the distance between the logic engine and isolated external venues. Because liquidity across the crypto market is heavily fragmented, algorithms are forced to constantly hunt, scanning dozens of disconnected order books for sufficient volume. This reliance on outside platforms carries a direct financial penalty. Routing a trade through an external exchange exposes the strategy to unpredictable third-party fees that eat straight into the profit margin. Even worse, the milliseconds it takes to ping those third-party servers introduce delay. In the time it takes to request a fill, the market moves, resulting in immediate slippage. To eliminate this delay, the physical gap must be closed. The trading algorithm has to operate directly within its own proprietary execution environment. For high-frequency models, predictive accuracy is only as effective as the connection to the order book. When execution lags, the gap between expected price and actual fill price becomes a structural tax on every trade. This terminal layout represents the Polar Exchange. It is a bespoke infrastructure solution designed exclusively to solve this latency problem, giving the Polar Tensor AI a native home to execute trades. The platform operates as a dedicated spot market, providing liquidity for 294 specific crypto assets, all quoted exclusively against USDT. It intentionally excludes other stablecoins like USDC. The matching engine requires strict, massive minimum liquidity thresholds to operate efficiently, and right now only USDT pairs meet that constraint. By focusing volume strictly into these specific pairs, the system targets its primary benchmark: pair matching and order execution in less than 10 milliseconds. To achieve this speed reliably, the exchange abandons the standard model of single-venue routing. Instead, it processes orders through a stacked 3-layer execution architecture. Replacing a single order book with a synchronized multi-layer architecture mathematically addresses the friction points found in legacy routing. To see exactly how this architecture reduces costs, we can track the lifecycle of a single large ETH USDT buy order. This diagram illustrates the 3 execution tiers. When the Polar Tensor AI identifies an entry, it pushes the order to the engine's top tier. This is Layer 1, the local order book, where the engine matches the incoming data packet against internal live liquidity. Within a sub-millisecond timeframe, the system scans the internal grid, instantly pairing buyers and sellers already operating on the exchange. Because both sides of the transaction are housed natively, the trade never physically leaves this closed system. By internalizing the match, the platform itself captures the spread, rather than paying that premium to an outside venue. For the trader, the result is the fastest execution time possible, accompanied by 0 spread and 0 external routing fees. But a single local order book has physical limits. When an algorithmic strategy demands a volume larger than the internal depth can immediately provide, the engine cannot stall. While internal matching delivers optimal cost efficiency, sustaining true institutional volume requires an automated overflow mechanism to handle the excess. When an internal match fails, the remaining volume drops into the middle tier, Layer 2, the AI Liquidity Scout. It uses a low-latency API to poll external networks, pulling full order book depths from 7 distinct liquidity venues straight into the central environment. By aggregating this data, the algorithm secures the most competitive pricing and accesses massive secondary depths, bypassing any internal liquidity constraints. If the requested volume exceeds depth at any venue, the system triggers its failsafe. The volume hits Layer 3, dedicated to smart order splitting. Instead of forcing massive blocks through thin markets, the algorithm chops requests into precise, smaller pieces. It then evaluates the connected venues, routing these fragments based on 3 parameters: the asset price, the available liquidity depth, and how quickly the venue can execute the fill. Because these pieces deploy simultaneously across different exchanges, the trader's total volume remains hidden from the broader market. Sending appropriate sizes to optimal depths ensures that every fraction of the trade executes at the best available rate, minimizing the total slippage of the aggregate position. Once the external nodes confirm execution, the engine instantaneously re-aggregates the individual fills back into a single cohesive order. By programmatically dissecting and dispersing the trade across layers 2 and 3, this architecture allows the algorithm to outperform the execution of any single venue exchange. Backing this routing engine requires a highly structured supply of capital. That capital is divided into 3 sections: Tier 1 handles general liquidity, acting as the primary pool for standard market depth. Tier 2 provides secondary overflow. It is engineered specifically to backstop the local order book and give the AI Scout immediate fallback depth. Tier 3 is specialized over-the-counter liquidity. This is isolated capital reserved strictly for processing high net worth and institutional block transactions off the main book. With the network architecture established, the only remaining friction point is how the user's trading logic physically accesses these pools. This illustrates the solution, a mirrored wallet architecture linking the trader directly to the exchange. When linked, the client's trading wallet and exchange wallet synchronize. Any movement, a deposit, withdrawal, or trade, is instantaneously reflected in both locations. By mirroring the balances natively, the platform removes traditional transfer times, erasing the final latency barrier between strategy generation and market execution. Deploying a sub-10 millisecond multi-venue routing network is highly volatile. Activating it all at once exposes the market to severe structural risk. To mitigate this, the deployment follows the strict 4-phase roadmap shown here. It begins with Phase 1, the pre-alpha stage. Engineers execute internal testing to validate architecture. Next, Phase 2, Alpha. The engine trades live using corporate funds to measure reliability. Phase 3, Beta, expands to general user funds, monitoring stability. Finally, Phase 4, Public Launch. Retail onboarding opens and the full multi-tier liquidity network becomes completely operational for the public. This slow roll deployment is a strict requirement. It is the only responsible way to ensure the system processes live algorithmic volume without triggering catastrophic slippage. The completion of this platform finalizes a massive engineering loop. It directly connects the intelligence of the Polar Tensor AI with the specialized execution of the Polar Exchange. By operating inside its own ecosystem, the strategy reclaims control over where it sources its liquidity and how fast it secures a fill. The physical distance that used to separate the logic engine from the order book has been entirely collapsed. In modern quantitative trading, strategy generation and execution are no longer separate functions. By collapsing the distance between the two, the infrastructure itself becomes a primary